Okay, now that we're back from the fire drill, which, did I jump? Probably did. There wasn't a fire drill. So, what we have here are the squares of the residuals. And this line represents the place where the sum of these squares is at their absolute smallest value it could be. And what we can do to show this is, I'm going to get rid of this line. And first, before I do this, I want to see here. Here's the sum of the squares for this, isn't it? And as we put this in here, the program will give us the sum of the squares. The sum of the squares is 2.226. That's the smallest squares that we can get to. Which basically means that what you're looking at is you're looking at the average distance of these of the line being from the points summing up to 0, but we're squaring them instead, because we might in some point want to use that value, and later on in statistics you would. So what I'm going to do is I'm going to get rid of the least squares line, but I'm going to put in a movable line, and it's got the squares in there too. And you can see some of these are huge. This line is just way off base here. And it says the sum of the squares, and you probably can't see it, but it's 57.71. So what I'm going to do is I'm going to grab this line, and I'll read this to you as we go.
Just to let everybody know, there is no problem with the fire alarm. Just disregard it. Thank you.
There's no problem with the fire alarm. So as I grab this line and I start to drag it down, my sum of squares has dropped now to 29.3. And I keep going until I try and get this as small as I can. We're at 18.82, 18.4, 18.40, 18.40, and that's the best I can do for moving this side. Then I'm going to grab this side and I'm going to do the exact same thing, and I'm going to try and minimize this as far as I can. I'm at 5, 4, 3.8, 3.2, 3.1, 2.87, 2.6, 2.5, 2.4, 2.3, 2.35, 9.3.355, 3.366. Close enough. And now I'm going to grab this and give it a little more tweak. See if I can get down to near that 2.226, 2.25, 2.4, 2.43 is as close as I'm going to get, and that's good enough for me, because I'm at 2.243 when the original was 2.266. So this means that this is probably, as far as me putting this in there by myself, that's probably a really good line of best fit, otherwise known as the least square lines, because what I've done is I've minimized the sum of these squares. Now you have to be careful, because is there an opportunity for some form of trick question when they're talking about the least squares and they talk about r squared? The answer is yes, there is. R squared does not refer to these squares at all. So be careful with that. R squared does not refer to this, even though it's given to you. R squared is not the sum of the squares of the least squares line. That's a completely different thing. We'll talk about R squared later. Right now we're talking about just minimizing the squared, or basically just minimizing the squares of the residual. And what I'm going to do is I'm going to put the least squares line back in here, and if we're lucky, we won't actually see a difference at all. And we don't really. You probably can't see it right here. This orange line is my line. This kind of turquoisey line is the least squares line, and they're over top each other here, and there's a slight difference over here. So I did pretty good. Here's the sum of the least, or sum of my squares, 2.243 in orange. Here's the sum of the least squares line at 2.226. So I was pretty close. My line has a slope of 0.0041. Their slope is 0.0039. My line has a y-intercept of negative 1.7. Theirs is negative 1.47. You know what? I'm pretty close. And if we could make a joke, say I'm close enough for government work, because I probably am. All right? So that's where we're at with the sum of the squares, or why it's called the least squares line. We're at 4 minutes left here, and we're just going to finish this one up here for now, and we will start day 2 next time.